All right, so let's take a look here. Parents, before we get started with the homework review, we're going to look at our exit ticket from lesson 23. And the objective for lesson 23 was to compare the size of the product to the size of the factor. And we discussed in class that factor times factor equals product. In this case, we have inequality, so it's not always going to be equal. We have our less than, our equal sign, and our greater than. So in order for these statements to be true, let's read the directions first. It says fill in the blank using one of the following scaling factors. These are my three scaling factors to make each number sentence true. So if you notice, the scaling factors are the numbers that are not going to be the same. So here I have 3 and 600ths, and I have 3 and 600ths. Therefore, we know that 3 and 600ths is equal to 3 and 600ths. So I'm looking for a number that's going to make, when I multiply it by 3 and 600ths, it's going to be less than 3 and 600ths. So in order for that to be true, it has to be a number that's less than 1, because we know that 1 times anything is going to give you that number. In this case, 1 times 5 and 2 tenths is 5 and 2 tenths. So therefore, if I want something that's less than 3 and 600ths, I have to multiply by something that's less than 1. I already used 1. The only number that's less than 1 here in my scaling factors is my 898 thousandths. So that would make this statement true. So, and let's take a look and see here. Now I'm looking at something. When I multiply it by 89 hundredths, it's going to be greater than 89 hundredths. So if I multiply 89 hundredths times 1, it's going to equal 89 hundredths. In order for it to be greater than 89 hundredths, I would have to multiply by something that's greater than 1. And 1 and 9 thousandths is greater than 1. All right. It doesn't ask us for any explanation. You don't have to write an explanation, or you didn't have to write an explanation there. Moving on to the next part. It says, will the product of 22 and 65 hundredths times 999 thousandths be greater than or less than 22 and 65 hundredths? So we have 22 and 65 hundredths here and 22 and 65 hundredths here. So this is my scaling factor. Is my scaling factor greater than or less than 1? Hopefully you said, call it out. Excellent. Less than 1. So because my scaling factor is less than 1, when I'm multiplying my scaling factor by 22 and 65 hundredths, the product of these two, factor times factor equals product, is going to be less than 22 and 65 hundredths. So we know that the answer is less than, and it says without calculating, explain how you know, and I just did. And we know that we can say because scaling factor, we'll put that factor in, 999 thousandths, that's in the thousands place, is less than 122 and 65 hundredths times 999 thousandths is less than, my first factor, which was 22 and 65 hundredths. All right, let's move on to our actual lesson for homework number 23, lesson 23, module 4, rather. So it says, sort the following expressions by rewriting them in the table. So we're going to take these 1, 2, 3, 4, 5, 6 expressions, and we're going to rewrite them in this table here. And it says, this first category is going to be the product is less than the box number. So the product is less than, so we're going to say greater than, less than, or equal to, and then we have this. So we should notice that our scaling factor is here, and I'll underline my scaling factor. So we're going to say this is greater than, less than, or equal to, in the box number here. So this is my scaling factor. Same thing here. It's greater than, or less than, or equal to. Put that number that's boxed in. It's a 2. That's my scaling factors underlined. Scaling factors underlined for all of the rest. And I'm just comparing using my greater than, less than, or equal to sign first, and then I'm going to go ahead and put them in the correct places. Greater than, less than, or equal to, 321 and 46 hundredths, greater than or less than or equal to 5 hundredths. All right, so let's take a look here. All I have to do is say, is my scaling factor greater than, less than, or equal to, greater than, less than, or equal to 1? In this case, none of them are equal to 1, so is it greater than or less than 1? I know that this is greater than 1. 1 and, once you say 1 and, you know it's greater than 1. 1 and 989 thousandths is greater than 1. So that's going to go on this side, because it's therefore, because this scaling factor is greater than 1, when I multiply that scaling factor by 12 and 5 tenths, it's going to be greater than 12 and 5 tenths. All right, so we finished that one. Let's take a look at this one. Is it greater than 1? 1 and, once we say 1 and, we know the scaling factor is greater than 1. 1 and 2 hundredths, so this is going to go on this list as well. 7 thousandths times 1 and 2 hundredths is greater than the number that's boxed, so it's greater than 7 thousandths because we multiply by something that's more than 1. All right, let's take a look at this. Is this number here 0 and 921 thousandths? That's less than 1, so when I multiply it by 828, it's going to be less than 828, so it's going to go on this side. 828 times 0 and 921,000. And if you notice, when this for B is asking us what do they have in common, pay attention to the pattern here. Let's take a look at this one. So we have 2 and 16 hundredths times 1 and 11 hundredths. Our scaling factor is greater than 0, so this, when we, is greater than 1. So when we multiply it by 2 and 16 hundredths, it's going to be greater than 2 and 16 hundredths. So it goes on this side here, greater than the box number side. You should start to notice something about these patterns here. Next, we have 321 and 46 hundredths times 1 and 26 hundredths. We know this is greater than 1. Our scaling factor is greater than 1. So when we multiply our scaling factor, which is greater than 1, by 321 and 46 hundredths, is going to be greater than 321 and 46 hundredths. So we would have to squeeze that in this box too. Try to get that in there. All right, so now we're finished with this, finished with that, finished with this one. Last but not least, 5 hundredths times 1/10. 1/10 is way less than 1, so we're going to say that that's less than 5 tenths. 5 hundredths. That's in the hundredths place. So this would go on this side. 5 hundredths times 1/10 is going to be less than 5 hundredths. All right, and it says, what do the expressions in each column have in common? The products that are less than the box number have a scaling factor that's less than 1, and vice versa. The products that are, the expressions that are in the greater than section, or the products is greater than the box number, have a scaling factor that's greater than 1. Okay, let's go ahead and move on. All right, next, for the next 5 problems here, it says write a statement using one of the following phrases to compare the value of the expressions. Then explain how you know. So we're going to talk about how we know. And the explanation can be super simple. Watch this. I'm going to say that that's my scaling factor. You see 14 here and 14 here. So I know that the 999 thousandths is my scaling factor. Now I have 2 and 6 hundredths here, 2 and 6 hundredths here, so this is my scaling factor. Same thing, this is my scaling factor, this is my scaling factor, and finally this is my scaling factor. So my scaling factors are underlined. So I know since this is very, very close to 1, 999 thousandths, if I get one more thousandth, it would be at 1. So that's very close to 1, so this is going to be slightly less than 1. That means that when I multiply 14 by it, it's going to be slightly less than 14. So I'm going to just write is slightly, less than 14. And we're going to write because, and I'll just write because 999 thousandths is slightly less than 1. All right, so now we say, well, look at our scaling factor here. If you had $1, of course, that would be equal to 1. If you had $1.01, that would be slightly more than 1. So this is going to be, when we multiply 1 and 100 times 2 and 600, it's going to be slightly more than 2 and 600. So we multiply by a number that was slightly more than 1. And we're just going to write, and I apologize for my print here, I'm writing on the computer screen. We're going to write 1 and 100th is slightly more than 1. And that's our explanation. So now we're multiplying by less than 2 hundredths. 19 thousandths is less than 200. So we're talking about money. This would be a little bit more than 1 cent, but less than 2 cents. Very close to 2 cents. So we know that this is a very, very far. 1 cent is very, very far distance, or a lot less than $1, right? So because of that, because this number is so far away from the number 1, it's a lot less than 1. We know that when we multiply 19 thousandths by 1,955, it's going to be a lot less than 1,955. Let's go ahead and write in is a lot less than. And we're going to say that 19 thousandths is a lot less than 1. All right. So now we have 2,000 times 1 and 1,000th. So we have all of our options, and we were comparing it to 2,000s. So we know that this is very, very, very close to 1. So this would be is slightly more than. Because this number, our scaling factor, is slightly more than 1. That means when we multiply our scaling factor times 2,000, our product is going to be slightly more than 2,000. So we know that 1 and 10,000th. All right, so now we have 2 thousandths times 911 thousandths. So we know that this is very close to 1, so it's going to be slightly less than. It's very close to 1, but it's below it, so it is slightly less than 2 thousandths. And that's because 911 thousandths is slightly less than, all right, moving on here. So we're talking about Rachel. Rachel is 1.5 times or 1.5 times as heavy as her cousin Kayla. Another cousin, Jonathan, weighs 1 and 25 hundredths times as much as Kayla. List the cousins from lightest to heaviest and explain your thinking. So I want you to think about this, and I would suggest using a tape diagram in order to find our answer here. So let's go ahead and take a look at this problem. All right, so Kayla would be the lightest cousin, and then Jonathan, last but not least, Rachel would be up top. So Jonathan would be in the middle and Rachel's up top. And this is how we came to this conclusion, or we should have came to this conclusion by simply saying, well, we know that Rachel is 1.5 times as heavy as her cousin Kayla. So we say 1.5 times whatever Kayla's weight is. So let's just say that for simple multiplication, let's use 50. So if Kayla weighs 50 pounds, we don't know this for sure, but we're just using the numbers to find our scale. And Kayla weighs 50 pounds. Her cousin Rachel is 1.5 times that. So Rachel equals 1.5 times 50. Because we know that 1.5 is greater than 1, we know that Rachel's weight is going to be greater than 50. All right, so if we need to do that out, we can do that. We can say 50 times 1.5. We're going to say, well, there's one decimal place here. 5 times 0, 5 times 5. Then we're on our ones place, 1 times 0, 1 times 5. We know that she would be 75 pounds. Remember, we had our decimal place here. We moved over, so we can move one place back over. So Rachel will be heavier than Kayla. Now let's look at Jonathan. Now we said, well, Jonathan weighs 1 and 2/25 times as much as Kayla. So Jonathan would be 1 and 2/25 times the weight of Kayla. So we know that this is closer to 1, so it's going to be less than Rachel. Don't be confused. I could put a 0 there for my placeholder for Rachel's weight, and that still has 5/10 is the same as 50/100. So we know that Jonathan would weigh, so let's go ahead and multiply Jonathan's weight just to double check. So we would have 125/100. So let's move that over 2 times 50. So we know that this is all going to be zeroed out. 0 times 0, 0 times 5, 0 times 2, 0 times 1. This was 2 places we moved over. 5 times 5/10 is 25/10. So I'm regrouping my 2 here. Then I say 5 times 2 is 10 plus 2. Let's get rid of that. 5 times 1 is 5 plus 1 is 6. Get rid of that. And I know that is going to be 6, 2, 5. And I had 2 decimal places that I moved over in my factor, so I need to move back over 2 places in my product. I get 62 and 5/10 of a pound, or 52 and 50/100 of a pound. So I know that if Kayla weighed 50 pounds, then Rachel weighed 50 pounds times 1.5, which would have been 75 pounds. And Jonathan weighed 50 pounds times 1 and 2/25, which would have been equal to 62.5 pounds. So that's the order. Kayla weighs less than Jonathan, and Jonathan weighs less than Rachel. All right, for this one, it says circle your choice. Remember, these letters are basically just substituting in for our question marks. They are variables. We can put any numbers in here to make it true. It says for this statement to be true, B must be what? Because it's saying greater than, that means that B must be greater than 1. All right, so we can write 2 statements that's true. Let's just use something simple. 2 times 1.1 is greater than 2. Everybody see that? This is my B. I'm subbing in and it's greater than 1. Now, on the opposite end, if for this statement to be true, B must be less than 1. So I can say 2 times 9/10 is less than 2. It asks for 2 supporting statements or expressions. So let's go ahead and give them another one. We say 2, and we're looking for something that's greater than 1. 2 times 22 is greater than 2. And in this case, something that's less than 2 times, and we'll use 22/100 is less than 2. And I wrote those statements here. That should have been down here. All right. All right, so this is a preview of that last problem finished the homework. Now we're just previewing for lesson 24. All right, it says an artist builds a sculpture out of metal and wood that weighs 14 and 9 kilograms. 3/4 of the weight is metal, the rest is wood. So first of all, I'm gonna pause right there and say I know that the rest would be 1/4. How much does the wood part of the sculpture weigh? So we know that the entire thing is how much weight? 14.9 kilograms. We know that the first 3/4, 1, 2, 3/4 is metal. That's the metal. and the rest is wood. That's the 1/4 is wood. It says what part of the, I'm sorry, how much does the wood part of the sculpture weigh? So we're going to say we need to find out if 1, 2, 3, 4, we have 4/4. Well, we know 4 units, and we can take this back, equals 14.9. So then 1 unit equals 14.9 divided by 4. And we're going to say that 1 unit, which would be 1/4 of the entire thing, is 14.9 fourths.